In this, my second talk on ethics and epidemiology, I'm going to talk about a number of issues that not uncommonly arise, and this includes what to do with medical data on a participant, particularly if we find something is amiss, what to do if others want to obtain our data to analyse it for their own purposes, and also some publication issues that often arise in epidemiology. So first of all, what happens if we discover health information, particularly potential health problems in one of our participants? So the basic principle is that study participants have the right to any information that we collect on them. And if we're going to deny it to them in some way, we need to, it needs to be justified. And sometimes there is information, such as from sort of say neuropsychology or cognitive testing, which doesn't mean very much at the individual person level. It only is really useful at the group level, comparing sort of average between one group and another, in which case that might be a reason why it's not useful to give people their study results. On the other hand, if we're, for example, measuring hemoglobin A1C, which is an indicator of whether somebody may be a diabetic, they have every right to that information. And certainly if we find that there is indications that they are an undiagnosed diabetic, we'd really have an ethical obligation to provide that information to them. So all of these things have to be thought about in advance of carrying out the study, and there may be instances, for example, the ApoE4 gene for Alzheimer's disease. Some people will not want to know the results of the genetic analysis, particularly if they have the gene which predisposes them to Alzheimer's disease, because basically there's not a lot that can be done about it at this stage. So it's better perhaps not to know about it. So they advise right at the beginning of the study they don't want to get that study result. But anyway, these things have to be thought about in terms of all the procedures that you carry out in your study, as to whether or not the results should be communicated to study participants and how they should be communicated. Certainly it's not appropriate just to pass the information to a participant's doctor, certainly not unless they have specifically given permission for that to happen. So we sometimes talk about linked and unlinked databases, and this comes into the impinges on these issues of confidentiality. A linked database is a database that either contains personal identifiers like name, birth date, social security number, or it would be easy enough to link that database to another database which contains those individual identifiers, and that can often be done through a study ID number, just to merge two databases. So if that is possible, then the database is still considered linked. An unlinked database is where the identifiers, or all possibility of linking the study data to identifiers, has been removed. So for that purpose you would perhaps have to delete the second database with the key to who everybody was. And IRBs generally insist on a plan for unlinking databases at the end of some point in the study. If you're not going to do that, then you really have to justify it. And a common justification for not doing that, not unlinking the data, is that you may want to carry out a follow-up study, in which case you would need to be able to identify who everybody was, because you want to compare the next set of data to the data you previously collected. So in any case, you have to actually provide the IRB with a plan as to what you intend to do. I want to mention HIPAA, the Health Insurance Portability and Accountability Act, and this, the provisions of this Act apply if you have, if you're in your study using healthcare information that's been collected by healthcare providers in this country, or so-called covered entities. And if you're carrying out a study in another country, even if it does involve data collected as part of the healthcare record, then HIPAA does not apply. So, but it certainly does apply if you're carrying out such a study in the United States. If you're collecting health-related information just as part of your study, and it's not going to enter into the medical record of the participants, then HIPAA does not apply. But certainly if any information that's collected as part of a person's medical record, then you need to pay attention to HIPAA and its requirements. So there are some basic procedures, ethical requirements that apply across epidemiology studies, and we've talked about most of these, but just let me run through them very briefly. Informed consent, we've talked about that. You need to get that from every participant. Personal data needs to be stored very securely, and the database that's being used for the analysis should not contain identifiers. There's really no need for the database used in the analysis to contain identifiers. If in the course of the analysis you find out something concerning about a particular participant, then it's easy enough to link through to find out who that person is, but the main database in the analysis does not need to contain those identifiers. And related to that, the key database that links the participant numbers to the names needs to be held very securely, either in a password-protected electronic database or in, say, a locked filing cabinet in a locked room, say. We need to justify to the IRB if we're not going to destroy all this identifying information at the end of the study. We've talked about that. We haven't mentioned so far that publications should present only aggregate data. In other words, you should never publish anything that could lead to the identification of a particular person in the study. And that's absolutely critical. That's an assurance that we give to people when they participate, that we'll only present aggregate or statistical data. Very important that all staff in the study are trained in privacy and confidentiality procedures. If one of them sort of violates some of those procedures, then it can cause all sorts of problems for the study. It could result in the study being shut down, and that certainly happens if just one staff member behaves inappropriately in a single instance. So we don't want that to happen. So we make sure that our staff are highly trained in these procedures. Finally, very important to adhere to high scientific standards. So some people say, well, why is this important from an ethical perspective? It's important for a whole lot of reasons, but particularly because we have a responsibility to our participants who are giving up their time, and they're divulging information. They're taking a certain risk in participating in the study, even if the risk is only that the confidential information about them will somehow be divulged and get to other people. But they're making a certain sacrifice in terms of time and risk of breach of confidentiality in participating. So it's very important that we adhere to high scientific standards so that they can feel confident that we're doing the right thing. And when I talk about high scientific standards, it has a number of components. And first of all, the investigators on the study need to be well qualified to carry out the research that they're doing. If they're not well qualified, then they're really violating the trust of the participants who have faith that the investigators are well qualified and know what they're doing. Need to use appropriate and up-to-date methods, needs to be appropriate quality assurance and quality control procedures, and all the study methods and procedures need to be documented. So this documentation often has two main components. One of them is the overall study protocol, which explains the rationale for the study, why it's being carried out, and sets out all the procedures, the timeline, the funding, so on and so on. So that's kind of like an umbrella document. Then for every procedure, and that includes things like interviewing or any clinical tests that might be carried out, or any procedures to measure exposure, any lab procedures, they all should have their own. Each one should have a standard operating procedure, or an SOP, as we usually say, and just to document what's going on. These SOPs have a number of purposes. One of them is to ensure continuity in study procedures if there's a changeover of study staff, so everything is written down clearly, and so they can pick up where the previous person left off. Also, when it comes to writing up the study, sometimes there's a gap between the end of field operations and actually preparation of publications, so that whoever's writing it up actually knows exactly the procedures that took place. Then you need these SOPs so they can consult them. And also, if you are thinking about getting further funding and having a continuation study, you may want to carry out similar procedures, and so you need to know exactly what you've done so far, or maybe you want to change them, but you need to know what sort of changes are going to take place, and how your data that you collect in the second phase actually relate to data collected in the first phase of the study. You need to have an adequate sample size. If your sample size is too small, then at the end of the day the results are not going to be very informative, and again you've let down your study participants. So adequate sample size, very important. Maintaining a documented database so that you know if you've made changes in some of the data, you know why it happened, in case you made a mistake and you have to go back. Very important, and that's really a basic quality assurance procedure, maintaining a documented database. The results of the study should be appropriately interpreted, neither over-interpreted or under-interpreted. They need to be interpreted in a balanced way, and related to that, study results should be written up and published. So that's a basic expectation of participants, also an expectation of funders and colleagues. So irrespective of the way the results came out, they should be written up and published. Unfortunately, as we've discussed, there's something of a publication bias in the literature, because studies of a certain category often don't get published. So speaking of publication, there's quite a lot of issues in publication, aside from just non-publication, and probably the most egregious is falsification of data. And this happens, unfortunately, all too commonly. Usually people get caught out because their results are not replicable. And so suspicion arises, and investigations occur, and it's shown, and there are many ways of showing it that falsification has taken place. And that really would be the end of anybody's scientific career. They cannot expect to get funding ever again, or to be published ever again. Another problem, all too common, is plagiarism. It happens a lot at all sorts of levels. And as a reviewer, I've had several, for journals, I've had several instances where I've received a manuscript and it has contained passages directly lifted either from publications of colleagues or publications of my own, in fact. But of course, in any area of research, there's a relatively small number of people who carry out that research, and there's a very good chance that they will be invited to be reviewers of a manuscript. So the chances of being caught out by colleagues in terms of plagiarism is quite high. But apart from that, there's a lot of software out there now which can compare text across publications. So the chances of being caught if you're plagiarizing are pretty good these days. The third issue is omitting inconvenient research details, which may in fact be key details, but they were for whatever reason inconvenient. sometimes the reason put forward for omitting these details is that the journal didn't give them enough words to write it all up, but that's usually not a legitimate reason, particularly if it is a critical research detail. Usually there's a way to fit it in, but people sometimes don't, and this does lead to apart from the non-publication issue, the omitting of key details is another bias that plagues the literature right across science, really, but also in public health and epidemiology. Redundant publication. This is where you publish basically the same stuff in more than one journal, or you attempt to do that. Journals get and rightfully so, very angry about this if they detect it, and it's likely to have unpleasant consequences for the authors. They may be barred from publishing in the journals where they've published redundantly, but also in many other journals for that matter. So be careful about redundant publication, and if you have two publications that are in some way related to each other, maybe they overlap a fair bit, then just tell the other journal, the second journal, that this is the case, and usually they're quite understanding about it, and there's ways around it, but you really don't want to be caught out after the fact. Another problem that's had a bit of publicity in recent times is the non-inclusion of the actual authors, sometimes referred to as ghost authors, but the inclusion at the same time of gift authorships. So the two really go together. Ghost authors may write the publication, and gift authors actually appear on the publication. So there was a recent instance of this a few years ago, revealed by the New York Times. A number of, or 26 in fact, scientific papers on hormone replacement therapy had been published for Wired Pharmaceuticals, and these publications emphasized the benefits of hormone replacement therapy and de-emphasized the risks. But the particular problem was that they were written by a consulting writing company called DesignWrite. And so the staff of DesignWrite wrote these publications, and then they invited various prominent physicians in the hormone replacement therapy area to be authors, but the DesignWrite authors didn't appear on the byline. So the impression given, of course, was that the prominent physicians and researchers actually had written these publications, and it had their full imprimatur, and but in fact it hadn't. They were like many people, pressured by the publish or perish way of life, and so many universities at the moment, unfortunately. So they may have read them, I guess, and signed off on them, but the fact is they didn't write them, and they simply took advantage of the offering to embellish their CV with more publications. So there's a much greater awareness of this problem now, and quite a lot of journals increasingly have these authorship forms where it has to be stated what each author contributed to the publication. So a couple more ethical problems in publication. I've already mentioned non-publication of results, so I won't spend any more time on that. But a particularly serious thing that's fairly widespread is non-disclosure of conflicts of interest. So I want to talk about this in terms of some examples. There are a number of published studies now that have actually examined this issue of conflict of interest, and one of these is a study that looked at the question whether there was a relationship between the published opinions of authors and their financial relationship with the industry that manufactured calcium channel antagonists. So these drugs are used to treat high blood pressure and also people with cardiovascular disease, and they're very effective, but at the same time they have quite a few side effects, and they have been with a high mortality rate when people have used them for an extended time. So a review was carried out of various publications, and these publications are actually reviews of the safety of calcium channel antagonists. So they found 70 reviews, and with a total of 89 authors, of which 69 or 80% replied to the survey, which inquired about their financial support for various purposes, attending symposia and so on, and also for research and general consulting. And the results were that 63% of the respondents had some sort of financial relationship with either the manufacturer or their competitors, but only 3% actually disclosed this potential conflict of interest information. And they found that in this review of the reviews, they found that there was a strong relationship between the likelihood of a positive review and the financial relationship of the author with a product manufacturer. And there's the full reference by Stilfox et al., which you can read if you're interested in getting more detail on this. The second study looked at reviews of the health effects of passive smoking or second-hand smoke exposure, and they wanted to find out whether there was any sort of association between the conclusions of the authors and their affiliations or sources of funding. So for this review they obtained 106 review articles which fitted their eligibility criteria, and they judged the affiliation of the authors from multiple data sources. So of course there are a lot of papers from the tobacco industry published online now, and so it's possible to search these papers for names of particular people, and a major database is actually held by UC San Francisco. Professor Stan Glantz has been instrumental in putting this online, so it can be searched to see who the authors are, to see where the authors appear in the tobacco industry database. And so they carried out a statistical analysis. This is Barnes and Barrow, and they are in fact from UCSF, Stan Glantz's group, I think. And they looked at the relationship between the conclusions of the reviews on passive smoking and the affiliations of the author, and they divide them into those who were tobacco affiliated and those who were not. And so this is basically the 2x2 table with the proportions here, and you can see that among the tobacco affiliated authors, 94% concluded that passive smoking was not harmful. On the other hand, among the non-tobacco affiliated authors, 87% concluded that it was harmful. So kind of a very strong reversal of conclusions, depending on whether or not the authors of the second-hand smoke review were affiliated with the tobacco industry or not. So, and they also point out that 77% of the articles did not disclose the funding source, but very strikingly, the odds ratio for having a tobacco industry affiliation and finding passive smoking to be not harmful was 88.4, with a confidence interval which well and truly excludes the null value, 16 to 477. and that was after controlling for a number of factors. So there's no doubt about it from that there's a very strong relationship between conclusions, particularly of review articles, and affiliations, particularly funding. So we always have to be very wary of that. Now, most medical schools, I think, and schools of public health have a tobacco funding policy, and the Berkeley School of Public Health tobacco funding policy was set out in 2006 after quite a lot of debate among the faculty. It may seem, or at least it seemed to me at the time, that it was we should just simply say nobody should accept any funding from any tobacco-related source. However, there were a number of faculty, very senior and respected faculty, who argued that that would be an infringement of academic freedom and we should not have any such blanket ban. And therefore, as a result, after the various perspectives were taken into account, the funding policy was issued. So it says, with due respect for the academic freedom of members of the faculty and their right to pursue any and all legal avenues of inquiry, the school strongly discourages faculty from applying for or accepting research grants or contracts from organisations known to be directly or indirectly funded by the tobacco industry. We also discourage faculty from applying for or receiving grants from tobacco industry sources through other units of the university. So that may seem a bit wishy-washy, but it seemed to work. And I believe that 6 years later, there has never been another research grant that has had tobacco-related funding. So it's worked, and basically it satisfied most of the faculty, particularly those who were concerned about violation of academic freedom. And you'll find, I think, that all schools of public health probably in the United States have some such policy, some of which actually just basically prohibit faculty from obtaining any money from tobacco-related sources. Another conflict of interest that arose was in the news not so long ago. It was over the prescribing of antipsychotic medications to treat this condition, somewhat controversial condition called pediatric bipolar disorder, which not everybody apparently agrees actually exists. But in any case, the problem arose because three child psychiatrists at a very prominent medical school in the United States, who were leading advocates of the use of these antipsychotic medications for this treatment, they failed to report drug company payments between 2000 and 2007. Or at least they seriously underreported what they received. They reported receiving around $200,000, whereas they actually received between $1 and $1.6 million each. And anyway, it had been expected to report it to the university, but they did not report it accurately. And this actually led to a Senate investigation. Now, a lot of concern because these medications have some serious side effects, and also the diagnosis of pediatric bipolar disorder increased 40-fold from between 1994 and 2003, and not least because these leading child psychiatrists had advocated treatment with these medications. So this is, I believe, an ongoing saga, some legal ramifications coming out of it, and we haven't heard the last of it. So I want to talk about a number of ethical dilemmas and concerns that occasionally arise when we're carrying out studies. And the first one I want to mention is whether or not by keeping participants fully informed, by providing information on our study hypotheses, we might be influencing their answers, because quite often people want to please, when they respond to our questionnaires, they think that by giving a certain answer, they will be. That's really what we want to hear, but of course that's not the case. We just want to get the actual information. So sometimes it's the case that we shouldn't be too specific about our hypotheses. And just to illustrate this, for example, when we, as you know, I carry out some research in developing countries on indoor fuel use and some diseases such as TB, and when we talk to the women, we will not say we're interested in your indoor fuel use. We'll say we're looking at household factors in relation to tuberculosis. So, and that's quite acceptable to the IRB, although we have to basically run these things past the IRB, get their approval. But the IRB does understand that we don't want to provide too much information on hypotheses, thereby influencing responses. So it's perfectly okay to say we're looking for household factors rather than looking looking at indoor fuel use. A second one that arises occasionally, it's arisen for me in a couple of studies that I've done where we've been collecting women's breast milk and analysing it for various fat-soluble contaminants. So breast milk is particularly useful for studying fat-soluble contaminants such as organochlorine pesticides, PCBs, and so on, just because it has a lot of fat content, where compared to blood, say, which has much less fat. When we enrol women, we don't want to put them off breastfeeding because we know that's overwhelmingly beneficial and certainly not in any sense outweighed by the very low levels of these contaminants that we might find. So we don't want to in any sense put them off breastfeeding. So we have to approach it very carefully. We need to have various consultations and discussions with the women so that they understand what we're doing, that we're using the breast milk because it's a convenient medium for detecting the very, very low concentrations of some of these chemicals. Anyway, it has to be approached in a delicate and careful way, preferably involving advocacy organisations for breastfeeding, having them come and reinforce the message that breastfeeding is best. Anyway, it has to be approached delicately. Another issue that comes up occasionally is when should an epidemiologist who is mainly involved in research suddenly become an advocate? And this can be a difficult one. Well, some things such as smoking, it's pretty clear cut. I don't think there's anybody who these days doesn't believe, is not completely convinced that smoking cigarettes, tobacco is harmful. But when you get into something like use of cell phones, then it can become a little more complicated, because there are people out there who are convinced that use of cell phones is potentially harmful, but many others, probably the majority, believe there is really no evidence. So at what point should an epidemiologist who's mainly focused on research, what point should they cross over and actually start saying that something is harmful? And that's a difficult one. Speaking for myself, I prefer, except in those very absolutely clear-cut cases like smoking, tobacco smoking, I mostly prefer just to remain as a researcher and stand aside from issues of advocacy, leave that to others, policymakers and so on. But that's something that every individual has to make up their own mind on, and it's difficult to give an absolute rule on that. The final issue I want to talk about briefly is the question of reanalysis of data by others. So we often get our funding from publicly funded organisations such as the National Institutes of Health, which is really the big funder in this country, and then we carry out analyses, we publish some papers, but then others may come along and say, well, we'd like to obtain your data because we want to do some other analyses. And so this raises some complicated issues because they may have a legal right to the data that you have collected. So the number of issues that arise around the reasons for the reanalysis, and the reasons for the reanalysis can range from the sort of very well motivated to the very malign, and it may be that they simply have an alternative hypothesis that hasn't been tested so far that they're interested in investigating, but they may, on the other hand, really be driven by concerns to overturn the original results, the original data analysis. And this may be tied up with commercial interests or legal proceedings, many things. Or they may simply even not seek to overturn your original findings. They may wish simply to, as they say, manufacture doubt. And simply by manufacturing doubt, that can have the same effect as actually overturning the original results. So the motivations of people who seek to get hold of and analyze your data may be very varied, and it can cause some real issues for investigators who are on the receiving end of a request. So, I mean, one of the issues that arises is, have the original investigators completed their own analysis of the data? So it's reasonable that the original investigators should have the first go at it. It would not be reasonable for the study data to be collected and somebody else to come along and say, I want your study data because I want to analyze it. It's only reasonable that the investigators who spent a lot of time and trouble in collecting the data should have the opportunity to reanalyze it, to analyze it themselves. And then there are issues about protecting the proper acknowledgement of the original investigators in terms of their collection of the data, and how to avoid unethical or malicious intentions of the people reanalyzing the data. Another issue that arises is that commonly, if you are going to hand over a database, it needs to be properly documented and properly explained, and there needs to be a way of responding to any questions or issues arising. But usually, for the most part, when we get our grant and we collect our data, we are not funded to prepare the data for analysis by other investigators, because to do this properly is actually a lot of work, believe me, and we are not funded to do it. So should we be expected just to drop everything else that we're doing and prepare a fully documented database and provide it to the people who request it? So that's a question. And then what about the issue of dealing fairly with discrepancies between the original analysis and these analyses carried out by others who want to carry out secondary analyses, whose motivations, as I said, may not be the purest. So I can't provide you with clear-cut answers to any of these things, but I just want you to be aware that these are issues, and a paper that discusses this fairly well by Raymond Neutra and others, published in Epidemiology. So I recommend that if you want to follow this one up, then seek out this paper and read it. So to my final slide, I've talked about a number of issues, some of them key issues in ethics and epidemiology, but there are many, many issues. And I've really only been able to scratch the surface. But fortunately, there are useful guidelines out there for epidemiologists, and one that I think is very good, very comprehensive, is produced by the American College of Epidemiology, and I give you here the link, the web link to it, and I strongly recommend that you read it. And there are other guidelines out there, and for the most part they cover similar but not always identical territory, but most of them will, all of them in fact, probably will cover the key issues, the ones that you're most likely to encounter. But for sure, if you go on to a career in public health or epidemiology, you will run into some of these issues. And hopefully these two talks have been useful, at least in sort of pointing you in some direction. There are ethicists out there who are available to be consulted. Guidelines and experienced colleagues are always useful if you run into any of these issues, and you surely will. So, I've come to the end of my talks in this lecture series. So it's been an interesting experience for me, mostly talking to a computer. I mainly, in my experience has been talking to classrooms of people, so I've had to adapt a bit, but I hope that I've managed to get across the same messages that I'd get across in a classroom. It's been a very interesting experience, and I've met a few of you over the last several weeks, and I hope to meet more of you. And always remember that I'm still here at Berkeley. I'll probably be here for quite a long time, and you have my email, and you can always feel free if you have any questions about either this course or about research or epidemiology when you go on in your careers. Always feel free to contact me and ask me questions. I'll do my best to respond. Try and remind me that you were in this class. It's a bit different to when I'm teaching people in a classroom situation. I get to know them all fairly well, but remind me that you were in my first online class, or second, or whichever it may happen to be when you're watching it. And anyway, I hope that some of you go on to successful careers in epidemiology, and that I will hear from you from time to time. So, all that's left for me is to wish you all the best and good luck with the remainder of the course, and also with completing your Master of Public Health.